Hello guys, today we are going to learn how to solve PDE using method of change of coordinates. So I'll start with an example. So let's say we have a PDE of this form. So what you do first is you assign each coordinate or you assign each coefficient to a variable. Are you getting it? So this is our PDE. So you assign each coefficient to a variable. So let's let my A to be 2, my B to be 3, my C to be negative 2, and then my F to be 1. Now after doing this, what you do next is, this PDE is in a function of u of x and y. So what you do is that you convert this to a u of x and n. You can use any variable at all. So after doing that, you assign each x and n. So assigning that, you are going to use x to be equal to ax plus by. And then we know our a to be 2 and then our b to be 3. So you substitute that into this equation. And then our n will be b of x minus, don't forget, minus a of y. A multiplied by y. And then we know our b to be 3 and then our a to be 2. So what you do next is you make sure for you to solve this differential equation, you have to make it a linear differential equation so that it will be easy for you to solve. So doing that, you are going to use this approach to convert this PDE into a linear differential equation. So you are going to use a squared plus b squared multiplied by u of x minus 2u equal to 1. So what it means is that you are just replacing the whole of this with this. Are you guys okay? So when you substitute this into the PDE, you will get this. And then we still know our a to be 2 and then my b to be 3. So when you substitute that, you get this. Are you okay? So when you substitute that, you get this. So after that, you simplify this and this will give us 13 multiplied by u of x minus 2u equal to 1. Now this is now in a form of linear differential equation, which will now be easy for us to solve. And we know that our u of x can also be written as our partial derivative of u over partial derivative of s equal to 1. Then you send this to the other side, which is negative will become positive. Are you guys okay? So now looking at this, we can use method of separation of variables to solve this. Are you guys okay? So this is also a function of u. We have u here. So what you do is that you bring this here and then you send this to the other side. Change of variable. So when you do that, you get this. Are you guys okay? So after this, we want to make our u the subject. So what you do is that you take the integral of both sides. So when you take the integral of both sides, you get this. And then anytime we integrate, we add a constant. So here our derivative is of form of c of x rather. So what you do is that our constant will be in a function of what? N. That means when we differentiate this back, we must get this. That means when you differentiate this with respect to x, it will be 0. So we will get this back. So from here, what you do is that you multiply both sides by 2 So this and this will cancel out, and then our 2 will be here. So when you multiply a constant by 2, you are still getting a constant. So that's why we maintain the f of n. So what you do is that you take the exponent of both sides. So you take the exponent, the ln will cancel, the e, so it will left with 1 plus 2u equal to the exponent of this function. So what I did next is I sent the 1 to the other side, which is positive will now be negative. So we have this, and then you divide both sides by 2, and then this will become, so the 2 cancel 2, so it will left with u. So I will divide the whole of this by 2. Now this, when you take the ln of this multiply by ln of this, I'll get this. Are you okay? We are getting this. So this, our u here is in a function of x and n, is here x and n, but in our question, our PDE is in a function of what? X and y. So what we do next is we make sure we convert our u, which is in a function of x comma n, into u in a function of x y. So that means we are just going to substitute wherever we see x, you substitute this. Wherever we see n, you substitute this. So this is, so we have our f of n, which will be replaced by this, and then this x, which will be replaced by this. So this will now be your final solution. Thank you.